Hi everyone. Today we will discuss about divide and conquer approach. The idea is same as a divide and rule policy implemented by British Empire to occupy India. If any particular problem can be divided into multiple subproblems of the same type, then we can apply divide and conquer approach. Here, for example, we have one main problem. We have one main big problem. Then, then we will divide the problem into subproblem. Subproblem 1, subproblem 2, subproblem 3, subproblem 4. Then uh, here it is we will do divide, and we will do for each subproblem we will do subsolution. Subsolution 1, subsolution 2, subsolution 3, subsolution 4. Then we will do last we will like this we will conquer. Then we will do combine main solution. So at last we will combine. The conditions here are first, the subproblem should be same type. For example, if the main problem it is sorting, the subproblem should be also sorting. If the main problem is searching, the subproblems we will divide into also each one should be searching like that. Then one more condition is there should be no overlapping of subproblems. The subproblems should be independent and there should be no overlapping. If it is overlapping, there is another concept we will discuss, dynamic programming. But here it should not be not overlapping. So here in this video we will discuss three topics that comes under or using divide and conquer. First one is binary search. Second one is quick sort. Third one is merge sort. We will discuss these three topics one by one. All these three topics are used by divide and conquer approach. We will discuss now binary search using divide and conquer approach. We already learnt binary search in normal method in searching algorithm. Please check in the codes. In normal method, when the mid value is not matching, we will change the start index and end index accordingly, right? In this approach, if the middle element is not matching, we will divide the respective subarray and continue the same process using recursively. Like let's take the elements 10, 23, 45, 70, 90, 100, 111, 123. Let's give the index for this 0, 1, 2, 3, 4, 5, 6, 7. Suppose the element we need to search is let's suppose it is 45. We need to search element. The element is here. So first we will do if the mid element is matching or not. That is 0 index plus 7 by 2, that is 3. So the uh, the third index value 70, it's not matching with 745. But if you observe the 7, first of all the everything is in sorted order. It is a sorted array. First we will do the sort. So what the element 45 70 is greater than 45, so the 45 then can definitely below the uh, third index, that is 0 to 2. So we will divide this uh, sub array into start 10, 23, 45. Now the start index 0, 1 and 2, like this. Then we will again do the same for subproblem. We again do the same searching. Now the middle elements 23 is not matching, but 23 45 is greater than 23, so it can definitely a right side. So I'm now taking whatever the right side part, I'm dividing the right side part I'm taking. So now for the 45, the start index is 2 and ending index also 2. So meet the 2 plus 2 by 2, that is 2. So element found. We will do this using compiler. The same thing I'm taking. You can pause the video and check the logic. So I'm passing the array, I'm searching element 45. So the same process, the base condition, these two recursive calls. So if I search this, the element 45 search found, but the element 1 2 3 4, the search is not found. So this is all about the binary search using divide and conquer. We dividing the main problem into sub problems recursively. Now we will solve quicksort algorithm using divide and conquer approach. Let's take elements. Actually, it's a kind of sorting only. We have already discussed some types of sorting, right? It is another way of sorting the elements, quicksort using divide and conquer approach. So here mainly there can be three tasks we will have, like the task one is there is one pivot element, there is a partition function, and there is divided into sub arrays. We'll discuss all three major functions one by one. So first I will discuss what is pivot element means. Pivot it's like in the physical form it looks like this. Some It is like pivot. If you put some bar, if it is weight is more, it will go like this. The weight is less here, it will go like this. Like if you do pivot, it will go the like this, the pivot. So the same thing we will do. We will take anything as pivot, like for example I can take this is 0 1 2 3 4 5 6 7 8. So suppose I will take pivot as the last index 8, 8 value, that is a of that last one. Now that is a of 8, the value is 8 here. So we'll simply do like what the code will be like. We will take first p index as starting, the start value is 0. So then we will do like from some I, from start to I is less than end, and I plus plus. We'll do if a of I is less than pivot, that is if pivot is greater than a of I, then we will do swap. What will swap here? A of that p index and a of I will swap. For example, take 0, a starting p index is also 0. So 8 is greater than 6, so we will swap. So both are at same index, so no problem. Then after we will do here we will do here p index plus plus plus. So that is now p index will be 1. Now after I also will comes to 1, I equals also to 1. Then again 7 8 is greater than 7. So again the process will go. So if it is not greater means we don't do swap, and we don't do the increment. So at the final how it comes means 8 will come like this, like after this function at the last we will do swap that p of index and p of end, that is our pivot will swap. So the 8 will come here somewhere. So then all the larger elements will be right side, all the smaller elements will be left side. So all the whatever the larger elements in any order, that will be at the right, all the smaller elements will be left, just like the pivot. The larger elements like will be right side, the smaller elements will be here. So then we will do for this again. We will divide now using recursions, the divide and conquer approach. So we will take here quick sort of the same uh, that array, and that is start and before p index before, right? So p index that is before, right? So we will take -1. So if after means there is p index, so starting from p index plus p index plus co- plus 1 comma end. So two recursions, like it can be like binary recursion. In a nutshell, what we are taking, I'm taking first to finding a pivot element, then I will do partition some separate function, then I will do the quick sort the left part and quick sort of the right part. So the same logic we will observe in the code. Observe here, the same logic we have taken. I'm taking an array, I'm doing quick sort. So is a quick sort array. So first I'm finding, we will say up to start less than equals to end. Index, we will take a partition of the same logic we have discussed, and then a quick sort of left side and quick sort of right side. So I will run this code. So you will check, you can see it, I have taken this 648391257. I'm getting the sorted array 1 2 3 4 5 6 7 8 9 9. So we have done quick sort algorithm using a divide and conquer approach. You can pause the video and check the logic here, uh, how the process we discussed. Now we will discuss merge sort. It can be done through divide and conquer approach. Let's take elements. Suppose 5, 20, 45, 30, 25, 10, 28, 40. The task here we should do sorting. Yeah, it's a kind of one of the way to do sorting. So now I'm taking indexes 0 1 2 3 4 5 6 7. First I will take mid, that is start plus end by 2, that is 0 plus 7 by 2, 3.5, but it is int, so we will take 3. So I will take up to 5 to this part, and after mid plus 1 to, that is you can see here, I will take from start to mid value, and mid plus 1 to end value. So I will divide it like this. And again for here, the start is 0 and 3. So 0 plus 3 by 2, 3 by 2, that is 2 1. So 1 is the mid year. So again I will divide it, that is 5 comma 20, and remaining 45 to 30. Then it will go like this. That out function is, I will take here, I will here, now I will merge it. Up to I will do merge sort. Now I will merge that is start, mid, and end. So here how will it be like, is it's the core idea is, the given array we will take mid and we will divide off. So again we will divide off of. So off in the third step we will do merge. The merge means it will be like the first one will be in the sorted form, the second also will be sorted form, that is two sorted arrays. So we will merge two sorted arrays. For example, now 520 we will take two arrays like that. So one is 5 element, one is 20 element. We will check if 20 is greater than 5, it is okay, but here if 30 is less than 45, so we will swap, that is 30 45. So again we will come 5 20 as one array, and 30 45 which are two sorted arrays. So we will check the first element with the first element. If it is sorted means then we will take one temporary array and we will store there. So the overall process will seems like this. We'll check first element with another first element, and we will if that is greater, so we will swap the functions. If that a of it suppose if a of I, if a of j is greater than a of I means we will swap and we will insert that into temporary value. Unlike so quick sort, the previous one, in the med sort we will use the temporary array every time. So I will show you the code so you can understand in a better way. See, just like I'm passing an array to med sort, that is first I'm dividing, then I'm just merging that two, that first off and second off. So for the first off I'm taking your temporary array, and I will take that I equals to start j mid plus 1, that is first sorted array 2, k equals to the start index of the temporary combined array. So then, so this condition, if a of j is greater than a of I, will simply do that in temporary array we will take that value. So or else in the temporary k we will take that second array one. So if it a of j is greater than a of I mean, so so at the last for I equals, so if still the element LAN elements is not present means we will simply move the right side like mid and end. So you can simply pass the code and you can check the logic. So I will run this code now. So I have taken 5 20 45 30 10 28. Now it is come in a sorted way. So it is one of the way to sort the elements in an array using divide and conquer approach. So this is all about code.